Hello class, welcome to our lesson today dealing with section 2.4. What we're going to look at is just a run through of a bunch of different types of graphs you might see and how they're set up. A lot of times you don't have to set these things up yourself, you just have to be able to recognize which one it is and be able to interpret what the information's saying. But we'll go through all the different types and then you can see if there's any questions at the end. The first one goes back to what's known as a stem and leaf plot, or also there could be what's known as a double stem and leaf plot. Stem and leaf plots are something you probably did way back, kind of in middle school almost, where the stem would be like the tens place, and then the leaves were all of the ones place. So like this first number is the number 4. This is the number 10 because the tens place is 1, so 10, 17, 18. Notice here there's two 23s, and it goes from lowest to highest. Really, this is just a version of a frequency distribution. So if you think about this is from 0 to 9 is the number 4, there's one number. This is from 10 to 19, there's 3 numbers. Okay, that's another way to look at it. So if you kind of turn your head sideways a little bit, this is similar to the frequency distribution idea that would become a histogram. So it'd start low, go high, and then come back low. So when you're dealing with some of these scenarios, it's not perfectly the same. But remember, it's probably tens place and then ones place. You might have one that's a double stem and leaf plot. What you want is the stem in the middle and the leaves go out. So the closest ones to the leaf should be the lowest. So if you're going one direction or the other, okay, it should start from like 10 to 11, 12, 13, etc. as you move your way outward in order to find all of those different answers. The next one is a bar graph. So bar graphs obviously are the most common. They're categorical. They show different frequencies or amounts of different categories. The second note might be a double bar graph, so that's what this one is. This would compare two different places about when they are, like this is cups of coffee sold downtown versus the mall location. And so you'll notice the difference, and you can see that they're selling a lot more in these 2 months, and it went down here. Okay, and all of a sudden the downtown's higher than the mall in April, and then it switches back. Okay, and it can be shown in a way to compare two categories of data that have a similar attribute. The next one is a frequency polygon. The key to the frequency polygon is it's basically a specialized type of line graph. It uses the midpoint, so like this would be like 40 to 49, and I just put a dot at 40, or I used the middle 44.5, and you just essentially, instead of where the frequency distribution histogram pieces go up to a certain point, you just put a dot in the middle of them and connect. So then you end up connecting all of those points to figure out what the frequency polygon looks like. And the idea is it just shows more of a trend line as opposed to just the bars from a histogram. But the idea is very similar, but it uses class midpoints as opposed to endpoints in order to figure out kind of where that middle ground is. The next one's known as an ogive. Now, ogives aren't used very frequently. The main thing about an ogive graph is the fact that it's dealing with cumulative frequency. And so what you'll notice here is if you keep adding up and adding up and adding up, this should constantly be going upward then, because you're saying, okay, if everything's less than a certain number, this is how many I have. If everything's up to a certain number, so like this could say, well, how many people are there up to 37? Okay, so here's 37. You go up to the graph. Here it is, and say, oh, well, there's just about 120 people. And so essentially, all it is your graphing as I keep adding. So if you see, this would be similar to if you've ever seen on a sporting event, kind of the graphs of like scoring. Okay, so a team scores, and then they're kind of flat for a while because then they score, and they score a lot, so it goes up a lot faster. That's similar to this idea as you're looking at this situation. Okay, the next one is what's known as a Pareto chart. The Pareto chart is a specific type of bar graph. I know it's hard to tell, but there is a little bit of a gap in each of these. So that's why it's a bar graph, not a histogram. You arrange the Pareto chart. Basically, it's just a specialized chart that bar graph that arranges from highest to lowest. This would be helpful if you want to be able to compare quickly who has the highest amount versus the lowest amount versus the middle. It's often combined with an ogive graph. So this line right here is just cumulative as you add them up. So here's the first one, and it adds the second bar, third bar, etc., until you get to 100% at the very end. The main idea to these questions is to ensure that you are looking at the highest to lowest. And again, that might be specific to the situation that you're dealing with. Okay, the next one is what's known as a time series graph. This deals with quantitative, so that's numerical data, okay, that's collected over different periods of time. And the goal is to show a trend as time goes on. One of the common trends that we see in a time series graph is something like the stock market. And so this is the stock market over time, and so it changes up and down. So here's the line of best fit. So you can kind of estimate where it's going to be, but it's very interesting to use something like this to explain historical events. For example, if you look right here, here's a huge drop-off in the stock market. That's the stock market crash of 1929, for example. Things go down and then kind of work back up. So this is still like recovering, and then the New Deal, and then World War II. And then it goes up, and here's a big boom right here. That's the big tech boom, kind of in the around 2000, 1990s. And if you keep this graph going, it's gone even higher and lower, housing recessions. And you can see from the dips and kind of raises from this graph what's been happening if you put a time series stamp on each of those big gaps or big changes in the graph. Okay, the next one is a pie chart. Don't forget pie charts, so qualitative data, so that's categories. And these are typically written as percentages. A lot of times you'll see pie charts without these percents, but I think they're probably most helpful to show the percentages with it. Yes, it's true that they show differences between those situations, but these two, for example, this thermoelectric and irrigation, are pretty close to one another. And so when you're dealing with those situations, it's helpful to know the percentages, so you can say, oh, well, this one is a little bit higher, but at least we know those two take the most amount of, like in this case, freshwater withdrawals compared to all the other ones combined. So when you're looking at some of those situations, you typically want to explain that. Don't forget that these should add up to 100%. With rounding errors, there may be a chance that it adds up a little bit differently, but it should be to 100%. And you'll notice pie charts show up a lot in kind of common newspaper language or magazines because they're visually easy to look at and appeal to people very quickly. The next one is a scatter plot. So a scatter plot takes two sets of data, okay, and two quantitative sets of data. So like this one is height and weight. And then you plot all the points and you kind of look back and say, all right, are these correlated in any way? These two have a positive correlation. The taller you are, the more you probably weigh. Now, there's not always perfect, okay, but it's in general true that a shorter person would probably weigh less than taller people, okay, as a general trend. I'm not saying that that's perfect, but that could be what's known as a positive correlation. If something would have a negative correlation, there would be a lot of dots to start with, and it would work its way down. And then it's also possible that you have no correlation, which means the dots are just randomly everywhere. And so a scatter plot can show you that very quickly. When you're dealing with that, you're looking for positive, negative, or no correlation. Okay, and again, StatCrunch and different programs can make scatter plots for you based on two sets of data, and then you can plot them very quickly to see if there is a correlation to them. The last one is what's known as a dot plot. Really, a dot plot is just each location. So this information is from an old commercial where it said how old is the oldest person that you've known. And what you notice is there's a dot here, dot here, dot here. That means there's one person that said it was in this category. There's two dots for like 71, for example. There's one dot here for like 109. And there's a bunch of dots if we counted them. Essentially, it's similar to the idea of a histogram. It's just very individualized. It's not a range of data to say how many are in that group. It's just saying each individual number about how to plot those. Not probably used as much as the histogram, but it does the same idea. Okay, it just stacks those numbers up on top of each other and then compares them. If you need to be more specific, the dot plot could be more useful, but again, it could just depend on that the information that you're looking at. Okay, so to recap, you want to have a basic idea about how all the graphs are set up. I'm not saying that you have to be able to draw them all out, but you should be able to look at one and say, oh, this is the dot plot, or hey, look, this is an ogive graph and here's why. Okay, those are some things that you want to be able to look at. I wanted to apologize for not being able to see all of the notes on the bottom corner. If you missed some of the notes, they're available in a PDF form as well, so you can get that if you needed. I tried to highlight what all those last bullet points were in case you couldn't see them. And you should be able to get everything you need based upon the PDF and the video. Have a good day, everyone.